Good afternoon, everyone.
Good afternoon.
Good afternoon. Thank you for being here today. My name is Jessica Minter. You may have received an email from me, maybe, but I'm the marketing specialist, marketing communication specialist here at nVent. And I'd just like to welcome you to our event. It's a huge, historic event. Excuse me, I'd like to recognize, we've got an eclectic group here today. So I just want to take a minute to recognize everyone that is here with us. So we've got IEEE leaders and members. If you just want to wave your hand, that's cool. All right, good. RAYCHEM alumni. Wow. Thank you for being here. We have Redwood City government representative. She will give us bring a greetings, in just a few minutes. And then we have one of our esteemed business partners here with us today. He'll also be speaking later. So I just wanted to thank you all for being with us, being here today. For the past several months, I've had the pleasure to put this event together, working with a very sharp and talented crew of IEEE members. So I'd like to just publicly thank Steve Jordan. Thank you. Dick Ahrens, who will be speaking momentarily. And also, I couldn't have done it without Chet Sandberg. I know he's a celebrity. So thank you very much. It's been great working with you guys to bring this forth today. For those that may not be aware of what IEEE is, what the organization stands for, it's the Institute of Electronics and Electrical Engineers. So one of the world's largest organizations that is dedicated to the advancement of technology. And nVent as a company, we adhere to the standards, and it's critical to our business, obviously. To provide you with some perspective, excuse me, let me get my clicker. Just a highlight of the agenda today. So we'll have welcomes. We will have our leadership team, Brad Faulkner, president of nVent Thermal Management, come forward and bring information about the company, the industry. Jim Jeffries, the 2019 past president of IEEE, will talk about the organization and how important this milestone is. And then we'll have historical commentary, and then the closing. We do have refreshments on the other side. You're welcome, if you want to get up, you're welcome to help yourselves on the way out. And we've got some gifts along here too that we'll be giving you later. Please do expect to be photographed. I'll be snapping some shots of those speaking, and then afterwards, if you don't mind staying back just a couple minutes, we'll take some shots too. But without further ado, I'd like to bring up Dick Ahrens. He is the milestone coordinator. Oh, I'm so sorry, I skipped ahead. Sorry. Shelley Macer, councilwoman of the Redwood City Council.
Thank you. Well, I'm certainly not the headline, so it's totally understandable. I just wanted to bring greetings and congratulations from my colleagues on the Redwood City Council. We love all of the creativity and inventiveness that happens in Redwood City, and we're very proud of our business partners, and so we are proud to have this award be recognized here in Redwood City. I was reading a little bit about it, and I noticed one of the things it did was protect pipes from freezing. And I am a former resident of Alaska, so I very much appreciate that I was able to get water when I lived there. But you know, Redwood City prides itself on being a place that's a welcoming community and a diverse community. And so that certainly means that we both welcome diverse residents, but that we also welcome diverse businesses. To have a business that's been committed to this city for as long as it has, since the 70s, is that right? Is that right, everybody? Yes. People with historical perspective? That really means a lot, that you would stay here, that you would make Redwood City your home, and that we have now apparently the second milestone unveiling of a Redwood City business, the first being Ampex. So I want to say congratulations. I'm excited to celebrate with you. I appreciate the technology that has made our lives better as a result. And with that, I will turn it over to Mr. Ahrens. So thank you so much and congratulations.
Okay, welcome everybody. Looking at this audience, looking at many more double E's here than this morning. Okay, so welcome. Okay, the actual milestone, the title is Invention of the Conductive Polymer Self-Regulating Heater. And we'll have a 22-pound brass plaque, which we will unveil by Jim Jeffries, and the plaque is sitting there covered right now. Okay. Jim will tell you more about the IEEE Milestone Program, its history, and about the IEEE, but this is the 200th milestone for the IEEE, and it goes way back to the Edison days. Okay. Well, fortunately, we have one of the two inventors today, Chuck Walker, and he will speak more about the invention, and we'll show you the patent which Chuck did back in, let's see, it was filed in 1972. And then, of course, Brad will talk on the impact of this invention, especially here at nVent. So we basically have the invention and the impact that makes a milestone. This is the 18th milestone unveiling we have done in our local section, which is basically the Santa Clara Valley section of Silicon Valley. Okay. And it is also the 27th in the West Coast region, which is called Region 6, which includes Hawaii and Alaska. Who's that mentioned Alaska? No. Okay, the local IEEE section with 18 behind us now is the largest number of any done by any IEEE section in the USA. Okay, Jim will sneak in Tokyo on that one. They outran us. Okay. Well, I looked at the list and I'm looking around. We have supposedly our present chair, Glenn Friedman, but I don't see him. And we got 3 past chairs of the local section. Okay, Joseph Way, I don't see him either.
Just trying to find the front door right now.
He's at the front door. And there's Fred Smith back there. Yeah. But Fred, you now have the honor to be at a power milestone. We didn't do too many of those, as you know. Okay. And we have Brian Berg, who's also a past chair. And Brian is also the regional history coordinator.
District chair of the Milestones Program.
That's the official title. Okay.
There's Glenn just for the back.
I can't miss Glenn. Okay, in addition, what I want to mention is that this event is also sponsored by the IEEE IAS Society, of which Steve Jordan is the current local chapter chair.
Thank you.
Yeah. Okay, that covers the power area, because I think we're dominated by the semiconductors and the computers in Silicon Valley. Okay. Now, lastly, I'd like to recognize Chet Sandberg, who spent 3 years on this proposal. He's the originator of the proposal. I got it through the IEEE. Now, when you see the plaque, the words on the plaque were vetted by over 20 and approved by over 25 historians. And that's usually tricky to push 60-odd words through 25 historians. Okay, Chet, good job. Okay, now from my point, let's go put it in the history books. Thank you, guys.
Thank you, Dick. Good afternoon, everyone. Great to have all of you here. All of our members, as introduced by Jessica, a bit of an alumni gathering too. I'm super proud and grateful to be part of this milestone. Myself, I've had 28 years next month where I started my career as an inside salesperson at a RAYCHEM rep distributor, learning about self-regulating heat tracing, and I think Chet was one of my first teachers about on the 101 program. This is a great honor to have all of you here to talk about this milestone, and certainly we're going to use this as an opportunity to broadcast this throughout the industry with the recognition and what we've accomplished. We had a great session this morning with all of our employees and certain communications going out around the globe. Chet joined us with the IEEE leadership for the employee meeting this morning, and Chet was sharing some great stories until they got maybe to where they wouldn't meet today's compliance standards. So I'm gonna share with you just a little bit about the company today, nVent, the importance of this technology to our business today, and a little bit about the future. First off, this site is our Redwood City campus. This is the home of our R&D center, our largest R&D center for nVent Thermal. Dr. Linda Kiss is head of global technology for all the thermal business. We're a global business unit within nVent with sites all over the world. This is also our largest manufacturing site. John Grants leads overall global supply chain for thermal, where we have our manufacturing of self-regulating heating cables, and we have produced over 1.8 billion feet of cable out of that facility. So quite amazing from that journey that many of you are familiar with, and probably some bumps throughout the years. So this is our Redwood City campus, and we are today part of a company called nVent. nVent itself is a new company. We were part of a spin-out of a company called Pentair just about a year and a half ago. We're a publicly traded company. NVT is a symbol. We're over $2 billion of revenue, and we are just 3 business units. So the thermal business that I run is over $600 million and one of the 3 global business units. This is our mission statement. I've talked to Chet. This really ties back to what we've done in our history with RAYCHEM, as well as what IEEE symbolizes, that we believe that safer systems ensure a more secure world, and we connect and protect our customers with inventive electrical solutions. That's the nVent overall mission statement. Our history in nVent is that all of the products and our key brands that make up nVent, many of them were original categories. They were the original inventors of complete product categories. Our earliest product invention came from a company called Aeroco. On the far left here, you can see back in the late 1800s, Aeroco stood for the Electric Rail Improvement Company, and they invented CAD-weld, which is still used heavily today in the railroad industry to connect rail ties. You can see that rail connection there in the bottom left picture. So for the thermal business, of course, our roots all stem back to RAYCHEM, where we have the founding of RAYCHEM, and that's radiation and chemistry, as RAYCHEM, as many people in this room know, and a picture of Paul Cook, who's sitting in front of me in the room, which was the founder of RAYCHEM, where many, many technologies and products in the electrical industry today came out of many of those early inventions from RAYCHEM. And ours is the RAYCHEM self-regulating heat tracing, to name a few. But the heat tracing portion of RAYCHEM is what made its way into our business unit today as thermal management. Our company headquarters is in Minneapolis, Minnesota. That's the nVent headquarters. And we recognize all the importance of our history in innovation in the electrical industry. Here is just, I wanted to show Paul Cook a picture of a conference room. It's a new headquarters, and all the conference rooms are named after innovators in the electrical industry Thomas Edison, Tesla, many others. It was actually Linda that came up with the idea and recommended this for the headquarters conference rooms. And we have the Cook conference room and a famous quote from Paul Cook. And whenever I'm in Minneapolis, this is the room I always reserve to have my meetings there. So special recognition. So there's probably only a few people in the room that don't know what electric heat tracing is. So there is a handout on the table here, and for a few of you, on the top left is a pipe with thermal insulation and an electric heating cable attached to that pipe. And what we're doing with our products is we're keeping the fluid in that pipe at a constant temperature. So like your home in the winter, when heat escapes through the insulation in the walls, the heater turns on and maintains that temperature. And that is a unique RAYCHEM self-regulating heat tracing cable. It invented and created an entire industry. What was most common back in the early days was steam tracing as the most common way to heat trace pipes and process. And this cable really revolutionized and created an entire industry. Today, our thermal business, we still heavily promote and utilize the RAYCHEM brand for our products. We are by far #1 in the world in what we do from all the work with many people in this room that we're a part of. It has created a much bigger industry. It's over $4 billion of electric heat trace products out there in the world that make up the total industry, adding services and even the alternate steam technologies. It's a very big industry that we're in a leadership position. On the right shows heat tracing is much bigger than just a cable. We have thousands of different cables for all the different applications. It's part of a big system that goes into a process pipe or on surfaces, and we have a full range of technology, electronic controls, software, and remote monitoring that makes up a complete heat tracing system. A little closer look at heat tracing self-regulating technology.
RAYCHEM self-regulating heating cables automatically adjust their power output to compensate for temperature changes. The outer jacket, braid, and inner jacket provide mechanical, chemical, and electrical protection. But the magic happens in the conductive core that surrounds the two parallel conductors. As the ambient temperature drops, the core contracts microscopically, and the number of electrical paths through the core increases. More heat is produced. Conversely, as the ambient temperature rises, the core expands and has fewer electrical paths. Less heat is produced. At a certain temperature, almost all electrical paths are disrupted and power output is close to zero. A self-regulating heating cable adjusts its power output along its entire length. That's what makes it a safe and reliable solution for many applications.
As many people in this room are part of, this technology really revolutionized the way that process pipes were heat traced and later went into many, many other types of applications. Here's just to show the breadth of different applications, installations. First picture on the left is a picture of a large Russia LNG project, one that we completed just last year called Yamal. This one project alone was over 3 years, over $100 million of revenue, and it was over 2 million feet of cable went into this installation in northern Siberia, where we heat traced pipes, stairways, you name it. It was a lot of heat tracing cable, control systems, and it was a significant achievement for us in some very difficult conditions to install and support such a big project. In the middle, there's probably in this room somewhere the original HWAT product manager, but in the middle shows our RAYCHEM HWAT system, which is used in many buildings to keep hot water systems running. In New York City, if any of you have traveled to New York City, it is a constant building boom, and we've had a significant win of large high-rise residential towers using our RAYCHEM HWAT system to maintain hot water and all the domestic hot water pipes. We've also had a very strong run here in recent years of expanding this product line to high-rise hotels in China. Here, we're actually providing green LEED energy points for building architects and building owners in order so that they can qualify for green, gold-rated LEED certified buildings. So really interesting and exciting achievement, and it's a big part of what we do in commercial space. On the right is the world's longest continuously heated pipeline. This doesn't use self-regulating technology, but after self-regulating, we continue to invent and develop many, many different types of heating technologies. This uses our RAYCHEM STS heating technology, where we can run extremely long lengths with a single power source. This is over 500 miles long and is in the Guinness Book of World Records. So really quite an exciting achievement that we're proud to talk about. So the RAYCHEM brand, the technology is so alive today, and it's part of who we are as a company, it's part of what we promote, and it is globally known and recognized in the industry as the gold standard. A little bit about the future. So this site, we, among many, many years, have continuously invested, and I just showed some recent years of investments. In 2013, we started to implement more of our lean manufacturing processes in our Redwood City manufacturing facility with some great improvements, and that really what led to our major investment in 2016, where we put $30 million into implementing improvements on this site with a new electron beam, upstream, extrusion equipment, R&D labs, the training center, this new building, and all the investments into the factory just behind us. So quite a big investment that we're very proud of. Some other achievements just recent years. So in 2017, we launched the industry's world's first low smoke, zero halogen self-regulating heating cables, which are used in commercial buildings. So this polymer product, when it's in a flame situation, it does not emit any smoke or hazardous gases. And it's the unique only product in the world that meets that standard, and it's really giving us a great spec advantage in the commercial building industry. So really great achievement by the team. This year we have some exciting work ongoing where we're providing finishing of our self-regulating cables in China and Russia. We've implemented a local assembly, braiding, outer jacket, printing, so we could get more local content qualified, keeping the core IP technology here in the US, but giving us more local content, and we're up and running in both those locations. And then 2020, as Linda says, stay tuned. We've got some really exciting new products that expand on our self-regulating technology with some great new R&D investments in process. So thank you. We'll certainly have some more at the end talking about some of our historical achievements, and but with that, I'll hand it over now to IEEE President.
Okay.
Jim Jeffries. Thank you, Jim.
Thank you. Well, it's an honor for me to be here today representing the IEEE Board of Directors, in this very special celebration of an IEEE milestone. And, I think this great story about the technology that you just heard is just further validation of why this is a milestone, an important event in technology's long history of advancements. It's also great to see that we have both a recognition and a reunion going on at the same time here. You see everybody an opportunity to maybe catch up and all been a part of this over the years that it's happened. So I was going to talk just a little bit about IEEE as an organization today, and then a little bit about the importance of history at IEEE, the legacy of history that's always been a part of IEEE. And then we'll move to the actual recognition and the unveiling of the milestone plaque itself. So IEEE today is the world's leading and largest technical professional organization with 420,000 members in 160 countries around the world. We continue to grow outside the United States. Half of our membership is now outside the United States. And our members today represent technology state of the art. They are in all areas. They are students, they're teachers, practicing engineers, they're innovators and researchers, consultants, and entrepreneurs are all part of IEEE today. So a very wide range, and we have a huge geographic breadth in our organization. We have about 120,000 student members in 3,000 universities around the world. So we have this incredible geographic reach. We also have technical breadth. With 46 societies and councils that focus on individual technologies along the way today, we connect the members through technology. We connect the members through geography. You heard the comments from Dick about the Santa Clara Valley section, one of our largest sections in the world, where we connect locally to our members with programs and events and get-togethers. We do it both technically and with geographically. We also connect with our members through affinity groups. So we have several affinity groups that our members connect in. One is Women in Engineering. We have 20,000 members in our Women in Engineering affinity group. We get together for special needs in those groups. We have young professionals. We have about 100,000 young professional members, defined as those people that are within 15 years of their first degree, who may have special needs in the growth of their career. We also have Consultants Network. And we also have life members. So those members who have maybe achieved a little age and experience and maybe in retirement, but also have a lot to still give back to the organization. So these are ways that we connect to our members with this geographic reach. We also have, this technical breadth. We run about 1,900 conferences a year. They're sponsored by IEEE in all the different disciplines. Usually they're the leading conferences in their areas. Our Explorer database today, which is where we keep the proceedings of those conferences, contains about 4 million articles. Downloads are about 12 million a month right now, and it's continuing to grow. So these are articles that have been peer-reviewed, extremely high quality. Our journals, 127 journals and transactions that we publish, are the most cited in the world for patents and for reference because they're peer-reviewed and they have extremely high quality. So we are very strong in the technical side. We also have standards. Many people know us by our standards. We have about 1,300 standards that we maintain today. We have about 1,900 standards working groups in operation, developing new standards in every area that it comes up. And one of the unique features of IEEE is we are a volunteer-led but staff-supported organization. So volunteer-led, writing our papers, judging our papers, running our conferences, standards working groups. This is work done by volunteers that are members of IEEE. And it's unique. Wherever I go in the world, people always comment to me, what an incredible resource this is, that the membership creates the value of the organization and actually consumes the value. So the members are extremely important to IEEE. We have a third dimension of IEEE, and that is social impact. And increasingly, we are projecting our voice into public policy. And whether it's in the United States, where we have IEEE USA focused on the US public policy. We have a European Public Policy Committee, but we also have other public policy activities in other parts of the world. So public policy and the voice of the engineer and the voice of technology. There are decisions being made that impact technology, or technology can impact decisions. We need to make sure that the voice is there. We also have humanitarian activities. Several years ago, the Board of Directors authorized direct support for Humanitarian Activities Committee. And so we fund projects on behalf of our members around the world. And these projects can be simple things. We have special interest groups in humanitarian technology, where a group of local members will identify a need, and that need will be funded by IEEE so that they can implement a solution. We're not humanitarian aid. We don't have the resources to do that, but we are about the technology that can solve some of the world problems. We also see increasingly that our technical history is one of technical specialty, and yet the problems that are being solved today are not within those individual specialties. It's very multidisciplinary, very cross-disciplinary. And so we have future directions committees, and we're opening up new areas, something like 5G. We used to call it 5G, we just changed the name to Future Networks. So it's not just 5G, it's going to be about new network designs, it's going to be about new transmission technologies, it's going to be about new frequencies for communication, it's going to be about all the changes that have to happen. The initiative that we have in new initiatives that has the most participation by our societies is the BRAIN Initiative. The whole idea that direct connection to the brain, so it involves neural networks, sensors, involves computational intelligence, involves all the things that would come together in these areas. So future directions and cross-discipline is a big part. Also ethics, continuing focus on ethics in technology. We've recently started a group of standards associated with ethically aligned design. In the design stage, thinking about the ethical problems when you have autonomous systems. Self-driving cars always comes to mind first, but it's deeper than that. As the Internet of Things and autonomous systems become more prevalent, there's ethical questions, and so trying to reach into those areas is also important to us. So that's IEEE today, an organization that is very much focused on the future, advancement of technology. Our primary mission is advancing technology for the benefit of humanity, and IEEE is very dedicated to that through all those different ways: geographic reach, technical breadth, and social impact, all part of IEEE. But I wanted to talk just briefly. Oops, I need to. Somebody throw the clicker here. So, IEEE has always had a legacy in history. Our founding goes back to 1884. Back in 1884, Edison and Bell and some of the people at the time responded actually to a show of interest article that appeared in a local trade magazine in New York City. And it's when they decided to form the American Institute of Electrical Engineers. They got together and they were concerned about several things. First was the public's need for increased technology. Electricity was becoming available. Communications was going to be possible. How is this going to be universally applied? And what about this nascent profession called electrical engineering? They were concerned about that. And so they formed this American Institute of Electrical Engineers. And ever since, we've been fostering technological advancement. That was done in 1884. In 1904, the Institute of Radio Engineers was formed, the IRE. So you had the power and the communications sort of things happening, and then you have the radio engineers came along. In 1963, those two organizations merged and became IEEE. So that's the long history of IEEE's legacy. And we continue to advance in all different areas. Our membership today is open to almost anyone who participates in the technical field. It's not related to a degree, it's not related just to electrical and computer, well, it is the majority of our membership. Anyone can be a part of IEEE and part of the history of the legacy here. So what are the benefits of preserving history? We believe very much in the value of preserving history. It increases public understanding of the achievements and the impact that engineers make. These technologies, and they don't always see it, but when they hear the stories, they relate to it, they understand. So enhances the image of engineers, elevates the prestige of the profession. It also helps to clear some misconceptions about engineers. Maybe they are actually innovators and not just doing calculations at a desk. So you have the opportunity to present the history. If people hear it, they want to be a part of it. They want to take care about it. Pride in accomplishments and preservation of landmark achievements that have happened. So there's good reasons that history can play in supporting the profession. So what can a professional society like IEEE do about that? Well, we can focus some things and some of our resources on history. So we have an IEEE History Center. The History Center is run in conjunction with Stevens Institute of Technology in New Jersey. Our operations center is also located in New Jersey. And we have a History Center at Stevens. We have a staff of about half a dozen PhD historians, and we do work very hard to collect things like oral and first-hand histories, articles and education material. We have archives of the history of IEEE back into the 1800s. You can go down in the basement, and yes, it is in the basement. Archives is supposed to be in the basement, I guess, but you go down there, and if you can find the archivist, you can open up the book and see Thomas Edison's signature and his member number 234. And as near as we can tell, he paid his dues on time. So it was really a lot of history associated with that. People look at that, they say, I like that. I want to be a part of that. And then we do milestones. And so we're going to talk a little more about the milestones as we're doing today. Milestones that try to put a permanent mark on the history and remind people of technology. We also have the Engineering and Technology History Wiki. So if you go to ethhw.org, there's a whole series of things. It's all open to the public. It's not a membership-oriented thing. But it's histories, it's the oral histories, it's connections, it's chronological activities, all things that have happened in technology, and a lot of interest there. So Milestones is one thing that we started. Now, Milestones Program was started in 1983. And we introduced the program as part of the 100th anniversary of IEEE, so part of our own centennial celebration. In that 35 years, we have been identifying things that have made major technological contribution to the world. We're looking for things that were the first, things that had lasting value, things that had a real impact. Those are the things that get into a milestone program. We don't put just anything in there, so sometimes it takes 3 years. You know, it requires that our members propose a milestone event. They do the research on why it was important. They gather the testimonials to back it up. They do the documentation and the writing. They get the words approved, and then they arrange the event like this. This is all done by our local volunteers. And so thank you guys for doing that here in the Santa Clara Valley section. It takes a lot of effort, but it leads to and we get them right most of the time. A couple of them that we've done recently, you know, they go back. The first milestone that we marked was Benjamin Franklin's experiments in publishing of information on electricity in 1751, which experiments he actually did in London. And you've probably heard the story about the kite and all. Well, we're not sure that it was actually a kite, but if you look at the IEEE pin today, it is shaped like a kite. So there's some connection that continues to go on there. But he did publish very significant documents from that experimental work that he did do. Recently here, Shaky, the world's first mobile intelligent robot. We did this, I think, 3 years ago. It's enshrined over at the Computer History Museum. It was a very interesting one, as well as batteries and other things. So these are very important, significant events that have happened, and we mark them. As already stated here, this is number 200. So in the 35 years that we've had this program, this is marking, which is significant in itself. And I think we've talked about maybe identifying the plaque in the lobby with further designation that it was number 200, which is significant. Another thing that we do from our History Center, keeping the history, preserving the history, researching the history is a charge to the History Committee from the Board of Directors. We also have a REACH program, and that's raising engineering awareness to the conduit of history. These are a series of programs that we developed that are aimed at late middle school, early high school students with an opportunity to think that when they think about the history, somebody might actually get the idea that they could be a part of a significant change, a significant event. Encourage entrance into the career and the profession of engineering. We have resources there and science and technology elements that are very helpful. And do so we're very focused on, can we bring a next generation, make them use the history as a way to make it straight. So you can all get involved. You are involved. You're here. Our members propose, do all the work to bring these along. All of these awards are supported by the IEEE Foundation donations. And so it's a program that's run through our donations, and it's administered by our History Center. But again, as everything in IEEE, driven strongly by the volunteers of IEEE and the organization. So with that, some history about IEEE. If you are members of IEEE, I'm proud to be your colleague. If you are not, membership is open to anyone in the technology field. I would guess everyone in this room is qualified, and we're welcome to have you as part of IEEE. As we continue on our mission, IEEE's mission, advancing technology for humanity, through all the resources that we have available, and an incredible volunteer base all over the world that's working on this every day. That's what IEEE is all about. So thank you for that, and now I'd like to move to the dedication of the milestone plaque itself. So the Milestones Program, as I said, began in 1983. Milestones represent significant accomplishments in a long history of technology's advance. And these events often are first of a kind or a unique activity, things that are built on top of it, things that have had a long legacy and a long-lasting impact. These are the kinds of criteria that come up in picking a milestone and choosing a milestone. Milestones give us a chance to help the public understanding of the impact of technology and the impact that the engineers, the scientists, and the technologists that did the work actually do. It's an honor to represent these things and to recognize them, and also the people behind them. So many of you here, the people that made this happen, is a big part of what milestones are all about. And so milestones also give us a chance to get visibility in the community. When people read the articles in the paper, or I've run into milestone plaques by accident at times. I was on vacation one time, we were talking about milestones with some people we were traveling with. They said, I think there's one over here. We went over there, and sure enough, there was a milestone plaque. It was the termination of a transatlantic cable, that had provided communications in the 1850s. Bronze plaque is set on a marble stone inside a fence. Very unique. So you never know where you're going to run into a milestone in IEEE. And one of our members tell us was at a hotel in New York City, and there's a dedication to Tesla in the basement of that hotel. He was just staying there. And the desk clerk said, "Would you like to see our basement?" Sure enough. So milestones are everywhere, and they can have a big impact. So they show what engineers have accomplished, what they can do. And engineers and scientists all over the world are doing this every day. It also takes a lot, and again, I'd like to thank the Santa Clara Valley volunteers who brought this milestone and made this particular milestone a reality for us. So now I'd like to dedicate this milestone. And in order to dedicate an IEEE milestone, it's our tradition that we do that by reading the citation itself. And it's time to enshrine this event as an IEEE milestone in electrical and computer engineering science. And this is the Milestone Unveiling. IEEE Milestone, Conductive Polymer Self-Regulating Heat Tracing Cable, 1972. In 1972, RAYCHEM Corporation patented and began producing the first commercially successful electric self-regulating heat tracing cable. The conductive polymer in this cable revolutionized temperature maintenance or process piping, which has had major applications in refineries and chemical plants, and made freeze protection of water pipes simple and energy efficient. By 2008, the firm had manufactured and sold 1 billion feet of this cable. We're ready. Thank you.
About 3 minutes.
Thank you, Jim. Sorry, thank you, Jim. We have a video that we wanted to show you. Let's check that out.
Our original technology was cross-linking crystalline polymers. That's how we developed heat-shrinkable products, because the crystalline polymers would have the crystals melt, and therefore the cross-links would take over and create the elasticity of recovery, which allowed us to have heat-recoverable products. Chemolex came along with the brilliant idea of having many conductive particles of a very small size incorporated into a cross-linked polymer, so that when you'd pass electricity through the conductive polymer, made conductive by the incorporation of the conductive particles, then that would get hot. What the cross-linked polymer chemistry allowed was then the polymers could get hot and recover from the cross-linking, which then in turn would allow the electricity to be either turned on or turned off. So we had the capability of passing electricity through a system, and it could either get hot by conductive resistance, or it could shut off and therefore be cold at room temperature. RAYCHEM was unique in that it was the first one to adopt radiation processing, radiation cross-linking of polymers. We were the ones that took the first GE-made electron beam generator, used the radiation from that to cross-link polymers and make industrial products from that process. And RAYCHEM was started on the basis of using the first industrial electron beam generator that GE ever made. And I had to hock my house in order to be able to get that privilege. But it worked, and it resulted in a very large company. When I retired, it was almost $2 billion a year, and I had been in a growth mode of 25% per year for 20 years. Very rapid. That's tripling every 5 years. The result of the combination of the Chemolex technology and the RAYCHEM technology was to have automatic control of the heat output and the temperature. By having the crystalline melting point of the polymers be at different temperatures, we could adjust to automatic self-regulation of heaters. And it worked brilliantly for the hundreds of products that we made from it. Let me invite you to step into the future with us.
Thank you, Mr. Cook. We're honored to have you here with us today. At this point in the program, we're going to move into historical commentary by some very special guests. I will just kind of call you by name to come up, and we're approaching the end of the hour, so 3 minutes or so per person would be good, but definitely say what you need to say. So can I have Jock Walker come up to the front, please? Your first up.
Hi, everybody. It's quite an honor just to be here to see what has happened to the simple little inventions that we started with. I think one of the key points that people should be aware of is not everything starts huge. Sometimes you need a little seed, and I'm stunned with what has happened to the seed that we put in the ground. I was an employee with Paul Cook's wire and cable plant, and I was hired over to build a machine to make a solution-coated fabric for Chemolex. And it turned out that the more we played around, we never built the machine because solution-coated fabrics don't work. It could have been the end of the project, but that was the idea. Chemolex made a product called ElectroWrap that was a flat film, and this was supposed to replace it with a positive temperature coefficient material. But those who've been working in the field will know probably why that won't work. It took us years to figure that out. But we decided, since my background was in extrusion, we decided to try extruding the material, and nobody valued what we were doing very much. So the only place we could get an extruder was to go into RAYCHEM's R&D after midnight. So this product, the very first product, was made after midnight in RAYCHEM's R&D. And it exhibited a stability that the solution-coated stuff never did, especially after cross-linking. So I'm humbled by where it's gone, what everybody's done, and the teams of people who've added to the simple start. But it's exciting, so thank you.
Thank you very much, Jock. Can I have Lynn come to the front, please?
Well, hello. So even though I sold Chemolex for about 10 years, I'm not here to actually talk about selling Chemolex because there are many stories you probably wouldn't want to hear that go along with that. But I'm here representing Jerry Delaney and Wells Whitney. Wells couldn't be here today because it's his 86th birthday, and he's got something better, he thinks, to do. And Jerry has written something that he wants me to read out to you. So Jerry, for those of you who don't know, was Vice President of RAYCHEM and Division Manager of Chemelex. So here's his story. After being with RAYCHEM for 7 years, I accompanied Paul Cook, CEO and founder of RAYCHEM, and Fred Grafton to Danbury, Connecticut. That was on the 1st of July, 1969. Mr. Cook announced the official acquisition of Chemelex Incorporated and its subsidiary, Electrotrace Corporation, by RAYCHEM, and introduced Fred Grafton as the newly appointed president of Chemelex. In the afternoon of that day, Bob Smith Johansson, R&D director of Chemelex, gave a demonstration of his new idea, a carbon-loaded self-limiting heater. I was not involved with the project of developing a self-limiting cut-to-length heat tracing product from Johansson's concept. This product was led by Fred with a highly motivated team, particularly R&D and manufacturing. Success was reached in 1972. This success was followed by many other contributors, patents, higher voltages, higher temperatures, changes to the NEC, and getting approvals from many agencies such as CSA, UL, Factory Mutual, as well as other international organizations and IEEE. At the end of the above efforts were, all of the above efforts were performed with enthusiasm, a sense of accomplishment, and a great deal of fun. For me, that's Jerry, it was a time unforgettable.
Thank you, Lynn. Gordon, please come up.
Thank you. Chet asked me to talk about one of the children of Chemelex, but I'll come to that in a second, because it's great to see the Chemelex business succeeding. Brad and Linda, great to see what you've done, all those new products and really long line heaters. Great to see that. But before I talk about that, I wanted to just say a couple of words about, it's great to be back and see this group of people I work with, Lynn and Jim, the product management group that I joined 40 years ago, Cliff Smith, Rob Hogue, Jim Barris, the guys I worked with and learned so much from. My story started 40 years ago. I joined RAYCHEM in a most unlikely place for the headquarters of a heat tracing business, Paris, France. Hired by Steve Bailog, sitting in the back, persuaded me to move to Paris, very difficult, to run the product management for the heat tracing business. After a year, as I was going to be introducing a new product we were making, the first high temperature STV product, they asked that I move here for a little while to learn firsthand about this product launch. So I moved here, and Cliff Smith, sitting there, who had joined same time as I had, he joined from Stanford, he went over to Paris to replace me, and I would come and sit in his office, and we'd work together collaboratively on this new product launch. I liked it here. It was great weather and could do outdoor sports and have lots of fun. Cliff found a nice girlfriend in Paris, so we kept dragging out so I stayed for 6 years, and Cliff stayed in France. And we had a great time in that product management, and the business was expanding. STV we launched several times. And then we had fiber products, which we launched several times. We had a lot of fun. During that time, I learned so much from Chet Sandberg. When I first arrived here, he gave me this tie. I've kept it for 40 years. It's a Chemelex tie. This tie, and this is a pipe with heat tracing on it, as you can see here. It might be the only one in existence, but I hang on to this and for special occasions wear it. So I was working with Chet, and he said, I'm going to be leaving Chemelex. Paul Cook has instructed that I have to move over to Menlo Park and work in a new group we're forming called GET'em. And I, GET'em? He said, yeah, it's the Group for Emerging Technologies and Markets. And we're going to find all these new applications. And I have this list he took out of his pocket, and he said, look, here's my 747 list. And it was all of these new ideas that you could do with the technologies, a lot of them from the conductive polymer material. And it went through all these different applications for using conductive polymer, not just for heaters, but one of them, he said, if we take a small sliver of a piece of heat tracing and we connect electrodes to it and we make it a little bit less slopey, with more steep RT curve, we can get much faster response. We could make a resettable fuse. And I said, really? So we'd replace all of the fuses in the world with a conductive polymer? He said, yeah, absolutely. These are the things that we do. This is what we do at RAYCHEM. And sure enough, Chet pioneered the whole concept of taking a very small piece of conductive polymer heat tracing, putting electrodes on it, making a resettable fuse. And today that business is several $100 million business that when Tyco acquired RAYCHEM, didn't fit there, so it was bought by Littelfuse. So those RAYCHEM people, many of them who have been around, are still inventing new products. And so that spin out of that technology from this business is alive and well today. And thanks to Chet and a lot of great technologists that helped develop that business and the culture that we had at RAYCHEM. So thank you to all of the people I've worked with over the time, and just some great experiences. Thanks to Chet especially, and of course to Paul. Thank you.
Thank you, Gordon. Quite impressive. All right, I'll have Larry Prentice come up.
Thanks, Brad and Chet and Jessica, for inviting me to this meeting and award. To be here for the award for inventing self-regulating heat tracing is very exciting to me. We've been in this business for 50 years. It's been very exciting and amazing business. Our company, Dale Prentice Company, was a manufacturer's rep company that had the opportunity to start with the company Chemolex, an electrowrap. Our company was started in 1926 by my grandfather as a manufacturer's rep. We had a number of products over the years, but to be here today to celebrate the invention of self-regulating heating is incredible. The history is really about the people, though, in this room. And it's wonderful to see the people that we've worked with for years. Lynn, it's great to see you. Jim, Pat, Steve Baylog, Gordon. It's amazing to me to be here. So thank you very much. It's an honor. Jessica asked me to talk a little bit about the history in our business. We started in 1965 as a rep for electrowrap. I think I still had some pictures. We have some samples still, I think, back in the office. For those of you that knew my dad, he saved a lot of things. So we still have pieces of electrowrap back in the office. Well, my father, Dale Prentice, he had the opportunity to bring this product line to our company. And he also had the opportunity to introduce self-regulating heaters to Dow Chemical. And Dow Chemical became one of the biggest users of self-regulating heaters in the world. So that was a great legacy that we had in introducing that product. I was born in 1957. That's the year, coincidentally, RAYCHEM was started by Mr. Cook. And Mr. Cook, it's such an honor to meet you. Your business skills, your engineering skills, the things that you've invented, I'm happy to be here and finally get to meet you. So thank you very much for that. The keys to our business is people. And as I look around, I see the people here. It just, to us in our business, the people side of this business, people invent products. And you put together the greatest people in a business that I've ever seen. We were happy to work with RAYCHEM and to work with the RAYCHEMers. This is something that in our business, we got to work with the smartest people in the industry. People with MBAs, PhDs, inventors. It was so exciting to us. But the most important part about that was even with that great knowledge, they were willing to teach us. So we were taught, as a sales organization, we were taught about products. We were taught about applications. We were taught about technology. We were even taught how to sell. So the group together here is amazing, and I think that's the most important thing to us as an organization. And for over 50 years, we've been in the business of selling heat tracing, and it's a sustainable product that I see forever. So when you go back to where it started in 1965 for us, when we represented Electrowrap, to where it is today, there's some great stories. We had some very memorable projects. I started with the business in 1982. My first job was to do a marketing study on the oil and gas business in Michigan. After going to engineering school and business school and living in Michigan my whole life, I had no idea we had an oil and gas business in Michigan. But my dad said, look, we're going to give him a little project to do where he can't disrupt any of our important customers. So I got to work with Shell and Amoco and some of those small customers in northern Michigan. We sold a lot of 4ATV to wrap it around the wellhead to keep that wellhead warm when it was minus 20 degrees in northern Michigan, to keep that product flowing. Well, one of the things I learned is that's probably a Class 1, Division 1 area. In 1982, we were learning lots of things. That's one of my first big mistakes. Also, the price of oil went down to below $20 a barrel, and we were no longer in the oil and gas business in northern Michigan. So, commercial failure, but from that, we had a lot of successes. But the successes really came from working with people. The project that I most remember is a project that I worked with Pat Mock. Pat's here today. It's great to see Pat. Pat was a regional manager in the Midwest, and we had, being from Detroit, the automotive industry was really important to us. Well, the automotive industry during that period of time was reinventing itself. General Motors had decided to build a Saturn plant in Spring Hill, Tennessee, a new innovative plant for assembly and manufacturing, but it was going to be started out in a cornfield in Tennessee, a clean sheet of paper. So with Pat's help, we were able to work on the specifications for all the heat tracing for the General Motors plant in Spring Hill, Tennessee. But also, we had the opportunity as the energy representative to sell all the high voltage splices and terminations on that project too. So that was one of the most exciting things I had to work with, but certainly working with Pat. And Pat was a very collaborative person and really helped us and made us a successful organization. We would not be what we are today without the associations and the things that I learned and our company learned from everybody in this room. So thank you very much. The other job I did with Mr. Thompson, in the commercial side of the business, one of the largest snow melting projects I think we ever had. Limited success, lots of issues, but we never walked away from the project. And the key to this was we tried different things. Not everything was a success. Sometimes you have to fail to be successful. So that was an important one also. The last thing that was really important to me is this company was very collaborative. I got to participate in the Representative Council. And at the time, it was Terry Melvin, Dave Megna, Don Cozzolino, and Mike Greasy. We were all on the council. And we got the opportunity to really help RAYCHEM navigate its way to innovative services and turnkey and solutions for customers. So those are kind of the three things that we really look back on in history and say, wow, what an amazing run. But the future is still there. And one of the reasons I was excited to be here, this company is now called nVent. We've been through 3 transitions. RAYCHEM, Tyco, Pentair, and now we end up with nVent. So hopefully, people invent products. The challenge that we have in innovation is the future innovation, the next generation. We have to work on it now. And it was great to hear what Linda's doing and all the projects that are coming up, Brad. I'm very excited about that. But we're here to support and encourage nVent, to invent and to innovate. So thank you very much, and thank you, Mr. Cook. It's a pleasure to meet you.
Thank you, Larry. All right, Chet, if you'll come up. I also need to bring up Glenn Friedman. He is the section chair of the Santa Clara Valley, and he has a presentation for you, Chet.
Nice to meet you, John. Good to meet you. I'm Glenn Friedman. I'm the chair of Santa Clara Valley section, the largest and most active IEEE section in the world. We've got nearly 50 operating groups. My best guess is at least one of those is doing things that you will be interested in. I invite you to talk to me and any of the other section members who are present today about what may be coming up just next month or two for you. Sunday morning, I got a special delivery from Robert Dent, the chair of the IEEE History Committee. The first item was a letter to the section congratulating on us on having this milestone. And as you've heard before, there have been a lot of them, and Santa Clara Valley section has had quite a few. The second is a certificate to be awarded to Chet Sandberg. So let me just read what's here. The IEEE History Committee recognizes and commends the efforts and contributions to the Milestone Program of IEEE made by Chet Sandberg in researching and proposing the Milestone Conductive Polymer Self-Regulating Heat Tracing Cable 1972. The dedication of which has increased the recognition by the general public of technical achievements in IEEE's fields and enhanced the appreciation of those achievements and their contributions to humanity. Robert Dent, Chair, IEEE History Committee. It's an honor for me to present this to Chet. It's an honor, Chet.
Thank you.
Would you like
Yeah, I'll take a microphone. Well, I'd like to thank everybody for being here. This has been a very special thing. Not only the 3 years putting the plaque information together, but seeing everybody here. Thank you all for coming. I had a comment on Ben Franklin's house in London. It turns out that's open to the public, and you should go visit it when you're in London next time. Also, what we have in AutoTrace is a nanotechnology thing. Nobody ever talks about it as nano, but what we have are the particles in there, which are a significant size, but then they get even smaller where they start touching each other. So we're one of the really first nanotechnology devices that was made. Also, it was the first product that RAYCHEM had that was active. Everything else just sort of sat there and did wonders by insulating and protecting mechanically. But this is the first one that changed its properties as things moved on. And then, as Gordon said, polyswitch grew out of that. So anyway, we have a picture here. I wanted to say a few things about Smith Johansson. Bob Smith Johansson was a brilliant inventor. He was from Norway and was interned during the Second World War and got out and went to the mountains and skied around and helped fight the Nazis up there. And so
he did that. Then he came and worked for GE in the silicone division. And that's why he was trying to get Jock to make this fabric thing with the silicones. And we're really lucky Jock didn't want to do a solution coating tower. So we got the extrusion capability. So Smith Johansson kept inventing things all the time. He wanted Paul to make a gasoline additive that'd get 90 miles to the gallon, you know, all this kind of wild stuff that he was doing back then. And this is, I went to see him in 1998 at his island just off the coast in just south of Oslo. So anyway, that's where we are. We've heard a lot about the technology, and what we really have here is a continuation of the DNA of RAYCHEM and Chemolex, and Brad and crew are now given the choice and challenge to move that forward, and I think it's going to be really good, and I'm really happy that you guys are taking over now. Somebody said that if you live long enough, your students will hire you, and that. So anyway, thanks for coming, and good seeing everybody.
Thank you all again. Just a reminder, we want to take some photos of the various groups that we have here today, and then don't forget refreshments and gifts over here. So thank you very much. Enjoy the rest of your day.